Good morning, guys, or good afternoon, depending when you're watching this video. So you guys should be watching this on Friday this week. That would be the 29th. So make sure you guys watch this video because this will be your lesson for today. So today we're going to be learning about order of operations. So a couple vocabulary words before we jump into some actual example problems is numerical expression. Numerical expression is a mathematical phrase made up of numbers, mathematical operations like addition, subtraction, multiplication, or division, and sometimes grouping like parentheses. And what we do with those numerical expressions is that we simplify them to a single numerical value. Okay, so when I say simplify the expression, that's what I mean. I want you to take the numerical expression that we're working with, and then you're going to take it to its final result, which should be one single number. We're also going to be talking about algebraic expressions. It's very similar to numerical expressions, but algebraic expressions include one or more variables within it. So, an example of an algebraic expression could be something like 2x plus 1, and examples like that. And we don't simplify algebraic expressions; we evaluate them, because we don't know necessarily what our variable equals to unless it is given to us. So we evaluate an algebraic expression by replacing each variable with a given number, and you guys will see that on the back side of this note sheet. So before we do some examples, I have our PEMDAS here. We should all be familiar with PEMDAS. PEMDAS is short for parentheses, exponents, multiplication or division, then addition or subtraction. So the reason why we have multiply or divide or then add or subtract is because when we use PEMDAS and when we're solving order of operation problems, we must solve, here, let me write it over here, left to right. So when solving a problem left to right, we should be able to notice what comes first. So if division comes first before multiplication in a problem, that's what you're going to want to do. You're going to want to do division before the multiplication. Same thing if you had addition or subtraction in a problem. You want to do the subtraction before the addition or the addition before the subtraction, whatever comes first. Okay, so let's go ahead and get into some examples here. Alright, so looking at number 1, we're solving left to right, and we have to use PEMDAS to help us when solving these problems. So when solving left to right, we have to think about PEMDAS, and we use it almost as a checklist. So what I suggest is write it on the side of the problem that you're dealing with. So remember, parentheses, exponents, multiplication, division, addition, subtraction. Okay. So when solving left to right, it looks like the first thing we have is parentheses. So we must solve everything inside of parentheses before we move on with the rest of PEMDAS. So I look here, I see we have 6 minus 2. So 6 minus 2 is 4. And then we have the cubed power on that divided by 2. And then we're done with parentheses. The next thing, because there's nothing else to solve inside of the parentheses, we just have a single numerical value, which is 4. Now, we have to do our exponents. So we do have to the third power on our 4 here. So 4 to the third power, if you use you guys' calculators, or if you think about 4 times 4 times 4, that would be 64. And now that we're done with exponents, we keep going down the list with our PEMDAS. I don't have multiplication in my problem, so I move on to the next step, which is division. So we have to do 64 divided by 2, which would be 32. And that's our final answer. And guys, when we solve our problems, we must make sure that our work is going downwards like this in an organized fashion. So make sure you guys are doing that. So now in number 2, we have 2 to the 4th power minus 1 over 5. So if we stick to PEMDAS, we ask ourselves, do we have parentheses? No, we do not. So we move on to the next step. Do we have exponents? Yes, we do. We have 2 to the 4th power up here. 2 to the 4th power, that is equal to 16. So I will say this is one of those problems where PEMDAS matters, but at the same time, we're going to have to actually do addition or subtraction before we can divide. And I know that's going out of the order of the PEMDAS, but whenever you have a problem set up like this in terms of a fraction, you must simplify both the numerator and denominator to a single numerical value. Then you will be able to divide. So 16 minus 1, that is 15. Excuse me. And now we move on to the next step in PEMDAS. We don't have multiplication because we know a fraction means to divide. So we need to do 15 divided by 5, which is going to be 3. And that is our final answer. All right, number 3. So we keep using our PEMDAS as a checklist when we're solving these problems. So looking at number 3, we have 80 minus 4 minus 1 in parentheses to the third power. So we think to ourselves, do we have parentheses in this problem? Yes, we do. We have 4 minus 1 inside parentheses. So that's what we need to solve for. So 80 minus 4 minus 1, which is 3. And then we have the third power on the base of 3 there. And 3 to the third power, that is 27. Because 3 to the third power is like saying 3 times 3 times 3, which is 27. And then we do our 80 minus our 27, which would be 53. All right. So those are the first 3 problems there. I'm going to go ahead and pause this video really quickly so that way I can scroll down to 4, 5, and 6. All right. So looking at number 4 here, we have 5 times 7 minus 4 squared divided by 2. So like I said, guys, write that PEMDAS in there so that way you can remind yourself when solving left to right what you need to do first, second, third, last, etc. Addition, subtraction. All right, so looking at number 4, we ask ourselves, do we have anything inside parentheses to solve for? No, we do not. I see no parentheses in this problem. Then we move on to exponents, which we do have. So we need to simplify 4 squared, which is 16. So we have 5 times 7 minus 16 divided by 2. And now we're down to multiplication, subtraction, division. And remember, we always solve left to right. So when solving left to right, I encounter 5 times 7 first, which is 35 minus. And then I keep solving left to right. I see division over here, 16 divided by 2, which is 8. Then 35 minus 8, 27. And this stuff should be familiar to you guys. You guys should have had order of operations in 6th grade, so hopefully this isn't too hard while I'm out. Number 5, very easy problem. So use PEMDAS to help you. So when solving left or right, do we have anything inside parentheses to solve for? No. We don't have exponents. We don't have multiplication, but we do have division. So 25 divided by 5 is 5. And then 12 minus 5, that is 7. Easy one right there. Then we have number 6. Again, so this is like our problem that we had up here with, I forget which number it was, 1, 2, or 3. Number 6. So we think about PEMDAS. Do we have anything inside parentheses to solve for? I don't see parentheses here, so we move on to the next thing, which would be exponents. So we have to evaluate this 3 cubed, which would be 27, because that is like saying 3 times 3 times 3. Then 7 minus 2. So 4 plus 27, 31 over 5. So we're going to go ahead and leave 31 over 5 as our final answer. And it's okay to get fraction answers. In pre-algebra, we're going to start getting used to getting answers that are not just traditional numbers like 4 and 5. The reason why I'm saying leave 31 over 5 as a fraction rather than convert it to a decimal is because it's just easier for me to check on quizzes and tests And I want to, before we actually start using decimals, I want to cover it in our decimal unit. So I'm okay with you guys leaving it as an improper fraction. So that's 4, 5, and 6. I'm going to get this erased, and we're going to move on to the back side. All right. Number 7, 8, and 9. So now we're evaluating expressions. It is no different than what we're doing before with the order of operation. Is very similar. We still have to follow our rules of PEMDAS. It's just that we have algebraic expressions now rather than numerical expressions. So in the front side of the paper, we simplified numerical expressions to one numerical value. Here, we're going to evaluate an expression for when they tell us what each variable is equal to, and then evaluate it. So we have x's, we have y's in our problems, and they tell us x is equal to 5 and y is equal to 2. Since we know specifically what those two variables are equal to, that means we can replace each x in the problem with a 5 because x is equal to 5, and then we can replace every y in the problem with 2 because y is equal to 2. And when you plug in, this is super important. I cannot stress this enough. Always, always, always use parentheses when you plug in. Please. So, when we're looking at these problems here, we have x squared, so we know x is equal to 5, so we're going to say 5 squared in parentheses here. Plus 5, because x is equal to 5, minus 12 divided by 2 squared. Okay. So, we follow the rules of PEMDAS. Do we have anything inside parentheses to solve for? We have parentheses, but nothing really inside to solve for right now. So, we move on to the next step, which is exponents, which we do have. We have 5 squared here, and we have 2 squared here, so let's get that done. 5 squared is 25. Plus 5 minus 12 divided by 4 because 2 squared is equal to 4. Now we move on to the next thing, which is multiplication. Do we have multiplication when solving left to right? No, we do not, but we do have division here at the end of the problem. So 12 divided by 4 is 3. 25 plus 5 minus 3. So now we just got to simplify this even more. So 25 plus 5, when we're solving left to right, addition comes first. 30, then we have this minus 3 here. Then 30 minus 3 is 27. So as you guys can see, evaluating expressions is just like your order of operation problems, just that your job is that you have to plug in the number that the variable is equal to before. Okay? So that's the only difference. So number 8. Guys, when I tell you to use parentheses, I really mean it, because when I tell you so many people in the past plugged 5 and 2 in for this problem and said this was 52. This is not 52. Remember, when you have two variables right next to each other, that means to multiply. So that's like saying 5 times 2, not 52. So we have 5 times 2 squared divided by 5 times 2. Because we knew that x is equal to 5, so we replaced our x for 5, and we replaced our y for 2. So we think about PEMDAS. We do have something to do in both sets of parentheses here. 5 times 2, so we have 10 squared divided by 10. Then we move on to the next thing, which is exponents. So 10 squared is 100. It's like saying 10 times 10. And then we have this divide by 10. So we just undo that process because 100 divided by 10 is 10. All right, that's number 8. So number 9 is no different, except that it's in terms of a fraction, so you know that we're going to have to divide by whatever x is. In this case, we're going to divide by 5 eventually. So we have 4y, but in this case, we know y is equal to 2, so we're going to replace y for 2, and when you plug in, use parentheses, plus 2 over 5. So we think about PEMDAS. We don't have anything inside parentheses, so we move on to the next thing. Exponents, which we don't have. Then we have multiplication with the 4 times 2, which is 8. And remember, with these problems, we got to make sure that our numerator and our denominator is simplified to a single numerical value before we can divide. So 8 plus 2, 10 over 5, and then 10 over 5 is equal to 2. And that's our final answer. All right, last 3 here. So they gave us different variables and different numbers that they equal to. So evaluate the expression when a is equal to 3 and b is equal to 4. So we're going to replace these variables for what they equal to when we evaluate them. So looking at number 10, we have 3 times b, which would be 4, so 3 times 4 there, minus a squared, which would be 3 squared because a is equal to 3. So we think about PEMDAS. We don't have anything inside parentheses to solve for, so we move on to exponents, which we do have. 3 squared is equal to 9. Then we move on to the next thing, multiplication, which we do have. 3 times 4, which is 12. Then 12 minus 9 is equal to 3. All right, same idea with the next problem. It looks very similar to number 10. So we have 2b squared, so we're going to say 2 times 4 squared because b is equal to 4, minus 7 times 3 because a is equal to 3. So, again, we follow the rules of PEMDAS. Do we have anything inside parentheses to solve for? No, we do not. So we move on to exponents. 4 squared is 16 because that's like saying 4 times 4. And then if you keep going left to right, you have 7 times 3 here. So 7 times 3 is 21. And in the next step, when solving left to right, it looks like we have multiplication here. So 2 times 16, which is 32, minus 21. And then 32 minus 21, 11. Okay, number 12, 3b squared plus 2 over a to the 3rd power. So in this case, we know b is equal to 4, so we're going to replace b for 4. So 3 times 4 squared plus 2 over a to the 3rd. All right, so again, when solving problems like this, we got to make sure we simplify. Oh, I didn't plug in my a to the 3rd. 3 to the 3rd. All right, so like I was saying, when solving these problems, we got to make sure that our numerator and denominator is a single numerical value before we divide. So we don't have anything inside parentheses. According to PEMDAS, we move on to the next thing. So we evaluate our exponent, so 4 squared and 3 cubed. 4 squared is 16, so we have 3 times 16 plus 2 all over 27, because 3 to the cube is like saying 3 times 3 times 3, which is 27. So, and then we evaluate the numerator. So when solving left to right, I have 3 times 16 here. 3 times 16 would be 48 plus 2 all over 27. And then we just simplify the numerator here. So 48 plus 2 is 50 over 27. And we are good to leave that as our final answer. 50 over 27 does not simplify to a single numerical number. And you guys don't need to convert that to a decimal, so we're good there. So that concludes the notes. But I want to talk about what you guys are going to do next real quick to make things easier for Miss Nay. So, after you guys finish watching this video and taking the notes, you're going to want to go to Canvas because I want to see if you guys learned something from today's lesson. So, if you go to Canvas, here, let me do this. Alright, so if you go to my Canvas page and then you go to Modules, So go ahead and go to modules. At the top here, this is where you're going to find the video. I'm just now recording it, so I don't have it uploaded into the module called Unit 2 Expressions and Equations. But I do have your check-in here. It is out of 3 points, so it is worth points. So please be sure to get this done, so that way you can get the points for the check-in, because I will be counting this towards your grade. So make sure you do the check-in here. So if you click the check-in, here, let me do it like student view here. Give it a second. Oh wait, it's because it's not published yet. Okay. Still not there. That's great. Leave student view. Everything should be. Let me just refresh this real quick, guys. We love when things don't work right. Okay. So anyways, I'll mess around with that. Maybe it's just because I'm doing it right now and it's not translating or whatever. But your check-in will be right here. If you click the check-in, it's just 6 questions. The first 2 are multiple choice. The last 4, you just write the answer in, and it's only 1 answer. So you just type the number in. And then the video will be here as well. It will say the name of the lesson, it will say video, and it will say the date that it's for. So make sure you click that for the video. Miss Nay should have headphones for you guys, so that should be fine. And she will pass out homework to you guys. After you finish your check-in, tell her that you're finished, and then she will give you your homework. And if you guys finish towards the end, they'll give it to you. She'll give it to you as you guys are leaving class today. All right? So please behave. I'm not going to be here Thursday or Friday. So Miss Nay is going to be letting me know if you guys do good or not. So have a good 3-day weekend, because we don't have school Monday. And remember, my birthday, September 1st. So it'd be nice to come back to school with a birthday present for me. Yay, Mr. D. But anyways, have a good one, guys.